Hello everyone. I would like to welcome you all in the lecture series of Basic Electrical Engineering. I have been discussing the previous semester university question paper of Basic Electrical Engineering. So far, I have completed 4 questions. Rest of the questions should be completed in this session. I request everyone to note down the important point from this lecture video. First of all, I am going to show you the question paper again. Later, we'll continue the remaining part of the question paper. As you can see, we have completed the questions related to module 1 and module 2 also. Now, let us move on the questions from module 3. First of all, I request you to read the question once. 5A. Let's read the question 5A. All of you can go through the question. Yes, what is in the question? With a neat sketch, explain the different parts of DC generator. There are different type of DC generator, and you have already learned the basic structure of DC generator. What are all the important components? All those things you have learned already. Now, how to answer it? So I'll be giving one tip for you. How the answer key look like? So please refer this slide. See, if you can able to draw the neat sketch of DC generator, you'll be awarded 3 marks. Then if you could explain the different parts of DC generator, definitely you'll be awarded for 3 marks. So total 6 marks. So I'll show you one simple notes related to the sketch of DC generator and the components details. So everybody please have a look on the screen. If you draw this particular diagram, area of cross-sectional diagram of DC generator, that is lot more enough for your exam point of view. So kindly draw once. You can pause this video and you can draw this particular diagram. That is more than sufficient. So here you have to mark what about the field system, whole assembly. Okay, what are the major subsystem of field system? Then you have to mark about armature core. So you have to mark about armature core. Then armature winding also you can mark. Later commutator. Why commutator is required? That you know, right? Commutator is also known as mechanical rectifier. Then brushes, to collect the current, we are using brushes. So these are all the things you need to highlight in your answer book. So further, if more time allowed, you can explain about field system. There are different subcomponents in field system. Yoke, this is outer covering, pole and pole shoes for producing the magnetic field. Then in order to improve the magnetic field strength, we have field winding. To explain in brief. Then you can talk about armature core. What is the construction of armature core? Why the laminations are provided? What kind of material it is made up of? Then armature winding. If I talk about armature winding, you have to explain about lap winding and wave winding. See, this is your lap winding, and on the right side you can see the wave winding. Take care that in lap winding, the number of conductor per parallel path will be always equal to number of poles used. Whereas the number of the armature conductor per parallel path S will be always equal to 2 in case of wave winding. This point you are supposed to note down. I think it's clear to everyone. This is needed for your numerical example as well. Many of the students are committing mistakes. How to take number of poles, how to take armature, how to take armature conductor per parallel path. That's a major doubts to most of the students. So try to mitigate the issue. Hope it's clear to everyone. So these are the points which you are supposed to add in your answer book. Moving ahead, 5B. Give the classification of DC generator. Obtain the expression for EMF equation of DC generator. What about the marks distribution? So if you can produce the classification of DC generator, you will be getting 4 marks. Remaining 4 marks will be allotted for the EMF equation of DC generator. So I'll be showing you how to write the answer. All of you can observe the screen. Hope the screen is visible. So classification of generator can be written in terms of a flow chart. DC generator is segmented into self-excited DC generator and separately excited DC generator. Again, no need to go for in-depth explanation because only 4 marks. If time allows, write 1 or 2 sentences about the self-excited DC generator and the separately excited DC generator. Self-excited DC generator is divided into three types. One is series generator. In case of series generator, armature and field are connected in series, where shunt generator, armature and field are connected in parallel. In case of compound wound generator, in a single generator, we'll be having both the shunt field and series field. If I talk about compound wound generator, it is segmented into long shunt and a short shunt generator. Again, long shunt and short shunt generators are divided into two types. One is cumulative compound wound generator, differential compound wound generator. This is a flow chart. This is more than sufficient for this particular question. If possible, write 1 or 2 sentences about this. Hope it is clear to everyone. Regarding EMF equation, you can explain EMF equation with the help of Faraday's law of electromagnetic induction. According to Faraday's law of electromagnetic induction, the EMF induced is directly proportional to rate of change of flux linkage, that is E is equal to d phi by dt. First of all, what is d phi? D phi will be depending on the number of poles and the total flux per pole, that is phi, p phi, where dt, it is 60 divided by n. N is known as the revolution, right? Then applying Faraday's law is equal to d phi by dt. By applying, you will be getting 5pn by 60 volts. Fine. Then you know that the number of parallel paths in a generator can be written as Z divided by A. What do you mean by Z? Z is known as number of conductors. A is known as the armature conductor per parallel path. That varies with respect to winding. What kind of winding you are using? Either lap winding or wave winding. Yes. Now, what about the average EMF generator? Our average EMF generator is nothing but you have to multiply these two components. One is 5pn by 60 volts, that is E average. That will be multiplied with the number of conductor per parallel path. Obviously, this will be the ultimate answer. If you can able to write these points, that is lot more sufficient for exam point of view. Most of the students are missing the valuable points. Please don't miss the valuable points and don't lose your marks. Try to convince. Your presentation should be good. Yes, try to practice it. I request everyone, don't read simply, you practice it. If you practice it, obviously, you'll be getting the result. Okay. Moving ahead, I'll be discussing about 5C. Give broad classification of transformers. Explain the construction of transformer. You know, transformer is a static device. Transformer is also operating based on the Faraday's law. That is, you can specifically say about mutual induction. There are two types of induction you can call self-induction and mutual induction. So for transformer, mutual induction can be applied. Yes. How to answer this? There are 6 marks now. How to answer? It's also 3 plus 3. 3 for classification, another 3 for construction. Construction is nothing but you have to explain about the components. That is called a construction. What about the construction of your house? You have to talk about slab, concrete, etc., etc. Like that, you can explain about the transformer construction. Now, how to answer? How to proceed further? Yeah, transformers. According to the construction wise, transformers are divided into core type transformer. Another one is called shell type transformer. Possible toy symbol diagram. Okay. Then you can explain about what is core type transformer. What about shell type transformer? At least 3 to 4 differences can be written. One more thing, transformation ratio. E2 by E1 is equal to I1 by I2 is equal to N2 by N1. That is called a transformation ratio. If the transformation ratio is greater than 1, then it is known as step-up transformer. If the transformation ratio is less than, if the transformation ratio is less than 50%, then it is known as step-down transformer. If the transformation ratio is more than 50%, then it is known as step-up transformer. Suppose if the transformation ratio that is equal to 1, then it is known as isolation transformer, or you can call it as 1:1 transformer. Those points you can write in your answer book. Yes. Regarding the construction, you have to give the sketch. Sketch is important. Fine. Then you can talk about what is the material, where the core is made up of. Core is made up of silicon steel. Why? Because silicon steel is having very less value of hysteresis. If the value of hysteresis is very less, obviously the hysteresis loss comes down. Also, the material which is made up of silicon steel, and that is laminated. Why laminated? Why does it laminate? Because to minimize the eddy current loss. So the transformer having this type of arrangement that you can specifically explain. So altogether you will be getting 6 marks. Okay, construction with the importance like what about the core, what about the winding materials also you can specify. Windings are usually made up of copper. All right, yes, this is the way how to proceed these type of answers. Okay, try to highlight the answer and write down some underline. You have to provide some underline so that evaluator can understand, the student know some important information about the transformer. So no need to elaborate, no need to write, no need to go like paragraph manner. You can write in points. That would be better. That is my suggestion. Okay, so let's go ahead further. 6a. Derive an expression for EMF induced in primary or secondary side of transformer. This is nothing but derive an expression for EMF equation of transformer. It carries the weightage of 6 marks. Let us go through the EMF equation. You have to explain the EMF equation, do the derivation. So one diagram can be drawn, like draw the transformer. Okay, like this, you can draw the core part. Okay, then you can draw the winding, primary winding. Like this. Similarly, secondary winding can be drawn. Then you can mark all the, this is your core and this is your winding. What is primary voltage? What is secondary voltage? Primary number of turns and the secondary number of turns. Like that, you can able to write all those things. Then how the flux will be transferring from primary to secondary. Okay. So if you draw such kind of brief information, you will be getting 1 mark. Then flux is also like a sinusoidal vary. Okay, there is a sinusoidal variation in the flux also. Therefore, instead of phi, I can write phi m sin omega t, where phi m is the maximum value of flux. Omega is nothing but angular frequency. Now applying the Faraday's law is equal to minus n d phi by dt. You should know the basics of differentiation. Then you can do the differentiation very easily. Okay. So please recall the calculus part. It is required for engineering. Calculus part is mandatory. So please recall the calculus, basic formula of calculus is equal to minus n d by dt of phi m sin omega t. Then I am getting minus n into omega phi m cos omega t. From this you can separate it. N into omega into phi m is nothing but em. Correct, no? Then omega, you already know that it's angular frequency. The relation between angular frequency and supply frequency, that is omega is equal to 2 pi f. 2 pi f radian per second, where f is the supply frequency, omega is the angular frequency. So similarly, we require RMS quantity. You know already what is root mean square value. That is ERMS. ERMS is nothing but EM by root 2. By simplifying, you have to simplify like 2 pi by root 2. 2 pi by root 2 is nothing but 4.44 f into phi m into n. Please note down this. You'll be getting very simple idea. No need to take it as a complicated thing. It is that simple only. Now, if I talk about the primary side, EMF induced at the primary side can be written as E1 equal to 4.44 F into phi m into N1. It is at primary side. Whereas secondary induced EMF is written as E2 is equal to 4.44 F into phi m into N2. That is happening at the secondary side. That is sufficient. This is what you are supposed to write in your answer book. Okay. We have completed that particular portion. Now I'll be discussing 6b. Derive an expression for torque developed by DC motor. You are supposed to derive an expression for torque equation of DC motor. That is also another important derivation. So how to make out this? So I'll be showing you. So everybody can see the screen. I hope everybody can see the screen. So torque equation means, so you know what is the basic meaning of torque? Motor is a mechanical device. Obviously, it produces the torque. Torque is the mechanical output. Input is the electrical. Electrical input, mechanical output. So that is the working of motor. Yes. So power developed, that can be written as PM. PM is nothing but work by time. Power, equation of power. So work can be written as, how we can able to write F into 2 pi r. 2 pi r is nothing but how 2 pi r, because the motor armature will be like this. Correct, no? To complete one revolution, what is the distance? Force into perpendicular distance, no. So we can able to write it as force into the distance covered is 2 pi r. Perimeter, it's a circular motion, no. So it is 2 pi r. Then time can be written as 60 by n. So further simplification, F and R can be written as in a together fashion, that is F into R, 2 pi n by 60. What is 2 pi n by 60? 2 pi n by 60 is nothing but angular speed. It is written as omega. Angular frequency and angular speed is indicated by the same letter omega. So mechanical power developed is T into omega. Now we are to talk about the input power. This is your output power. What is output power? T omega. What about the input power? So input power is given by EB into IA, where EB is known as back EMF. Without back EMF, motor never be operated. Okay. So they may ask in another way, write the significance of back EMF. That is another type of question. Got explained. It will act as a self-regulating machine. Without back EMF, the motor will be stationary only. There should be always the difference between the terminal voltage and the back EMF. Correct? Because of that, there is a force which is developed on the armature. Armature starts moving. Similarly, we are assuming that the input power is equal to output power. Electrical input will be equal to mechanical output. So we'll be writing it as P is equal to PM. What is PE? P means electrical power. PM means mechanical power. PM means TA into omega. P means EB into IA. So you already studied that the back EMF can be written as Z into N into 5 by 60 into P by A. That this is a standard formula of back EMF. In case of generator, it is a generated EMF. But in case of motor, it will act as a back EMF. Formula remains same. The segments, the components which are in the motor and generator both are same only. DC construction wise, the DC generator and the DC motors are identical. That points you have to remember. I think you are following me. So please substitute the value of EB here. Then IA as it is, TA into omega can be written as 2 pi n by 60. Further simplification, do the simplification, simple mathematics. Then you can separate TA is equal to 0.1595 into IA into PZ by a Newton meter. Don't forget to write the units. Units are very important. So this is the final expression for torque. I think it's clear to everyone. Please follow this. All right. Moving further, I think you can note on the derivation. It's a simplified one. Definitely you can make use of for your university examination. So question number 6C. Can you read the question? Whenever you are reading the question, please note down the important points. Key points you are supposed to note. Given data. I mean given data. A 250 kVA power rating of the transformer is given. 250 kVA kilovolt ampere. 11,000 bar 415. 11,000 at primary side, 415 at secondary side. Obviously, it's a step-down transformer. Operating frequency is 50 hertz. And there are secondary number of turns as 80. You need to calculate the rated primary and secondary current, number of primary turns, maximum value of core flux, and the voltage induced per turn. Here, what are the things you need to know means the EMF equation. What is EMF equation? Is equal to 4.44 into F into 5 into N. This is EMF equation. Another thing you need to know, E2 by E1. Somebody will write V2 by V1. Both are correct only. Similarly, you can write I1 by I2. I1 by I2. That is equal to N2 by N1. N2 by N1. That is nothing but K. You need to know this formula also. Is it okay? By applying these two equations, very easily you can solve the problem. I promise you. So how to make out? First of all, you write the given data as like this. Everybody please observe here. So writing down the given data. Thereafter, how to calculate I1. What is current? Current is nothing but power by voltage. KVA means is the power, no? See, people are getting confusion. Power, simple equation for power is equal to voltage into current. Here I am asking you to calculate the current. Current is nothing but power by voltage. No, power is how much? 250 into 10 to the power 3, because 250 kVA will be converted to VA. In the denominator, it is in terms of volt only, because so that I will be taking uniformly. So if I do that, I will be getting I1 is equal to 22.73. Likewise, secondary current, kVA divided by V2. So you have to take the same power, because in transformer that will not change the power. Power remains same, frequency remains same. What exactly changing? Only the current and voltage. That point also you have to remember. Otherwise, people may get confusion. Yes. I2 is calculated according to kVA by V2. I'm getting 602.41. I request everyone kindly verify the answer. So take a Cal C, parallel you please verify, because I have done manually, because in a hurry, I made a calculation and just made it because your exam is very near. That's why I made out. So students, please calculate it accordingly and verify the results. If any anomaly found, please inform me. You can put up in the comment box. Yes, thank you. Now I am going to discuss about how to calculate N1. Use the transformation ratio V2 by V1 equal to N2 by N1. Someone will write instead of V2, they can write the E2 also. There is no objection. Then N1 can be calculated. 21 turns. I have got 2120 point some value fraction, but the turns means you take it as a finite value, right? Don't take the decimal. Then maximum value of core flux you can compute using the EMF equation. Either you take primary side or secondary side. Both are okay. I have taken secondary side. E2 is equal to 4.44 F into 5M into N2. From this, I could separate the value of 5M. Use the simple mathematics. Then I am getting 0.0234 Weber. If possible, express in terms of milliweber. Both are correct. Whichever you comfortable, you can go ahead. There is no restrictions. Then voltage induced per turns. What does it mean? Volt per turn. Voltage induced per turn means divided by turn, no? So V2 divided by N2. Otherwise, you can write V1 divided by N1. Both are acceptable. So if you solve these things easily, I promise you that you will get 8 marks. So clearing the subject is not a big deal. You aim for good score, right? And parallelly, try to build a good basics that is required. If you are preparing for competitive examination, that is needed. Yes. Now, we'll be moving on to question number 7. Okay, question number 7, 7A. Question number 7 in module 4 is mainly focusing on the AC machines, such as in 3-phase induction motor and 3-phase synchronous generator. 3-phase synchronous generator is also known as alternator. So let's solve the problem related to 3-phase induction motor and alternator. So don't leave any of the topic. Both are fundamentals. Every engineer should know about the machines. So that's why they have added in your curriculum. Module 4, 7A, explain the concept of rotating magnetic field in case of stator field of a 3-phase induction motor. The concept of rotating magnetic field is very important. So therefore, we can call induction motor as a rotating transformer. Everybody know that transformer doesn't move, but idiom, some kind of idioms, we can call it as induction motor is also known as a rotating transformer. Why? Because in induction motor, there is a production of rotating magnetic field. So you need to write some expression for rotating magnetic field. So how to write? I'm here to help you out. So a diagram is mandatory. Simple waveform, 3-phase waveform, you know, right? Supply voltage, stator voltage. You are providing the stator. Input will be electrical energy. 3-phase input will be providing to the stator. So that 3 waveforms, you can R, Y, V, corresponding VR, VY, and VB can be drawn very neatly. Definitely credit will be given for that. Later you have to mention about what about the flux. Flux is having sinusoidal nature. Phi R can be written as phi m sin theta. Phi y will be written as phi m sin theta minus 120. Phi b can be written as phi m into sin theta minus 240. If you write it, definitely you will get another 3 marks. Draw the vector diagram. Apply the parallelogram law of vector addition. If I apply the parallelogram law of vector addition, phi r equal to 3 by 2 phi m. Or else you write it as phi r. Phi r is the resultant flux, that is equal to 1.5 times of maximum flux. So if you require I'll be doing the video. So far I covered up to 2 modules. Remaining modules I have to cover in recent future, upcoming days I have to cover. If you require the simple derivation, you can contact with me. You can write a comment on the comment box and give your mail ID. I haven't made a drive actually. I would have done it. Everything should have been stored in my separate drive. That would be useful. Let me try for that. Right now, you can share your mail ID. Definitely, I will do it. Okay. Otherwise, my mail ID will be given at the comment box, in the description box. You can check my mail ID and forward whatever is the query. Definitely, I will revert. So this is your ultimate expression. Suppose if you don't know the derivation, kindly write the phi r equal to 1.5 into phi r. These things you can write. At least some credit, 25% or 30% marks will be given for that. People are I found that I have attended many evaluations. Students are actually not putting the question number. Students are not ready to write the equations, all those things. Simply losing the marks. So I have seen many times such kind of things need to be avoided. Now 7b, you can pay the attention on 7b. Yes, define slip of an induction motor, derive the expression for frequency of rotor current. So you have to explain about slip. What is a slip? What do you mean by slip? And derive an expression for rotor frequency, F dash. Slip you can define in this fashion. So it is the ratio of change in synchronous speed and the rotor speed to the synchronous speed. So mathematically you can write like this. So this is a final expression for slip. Now we have to derive the rotor frequency. Okay. Anyway, you know the working of induction motor. So slip is very important. So first of all, you can write ns minus n, difference between synchronous speed and rotor speed, that is equal to 120 f dash by p, where f dash is the rotor frequency. ns equal to 120 f by p. Ns is known as synchronous speed. So f is the supply frequency. Don't get confused about f dash and f. F dash is nothing but rotor frequency, where f is nothing but supply frequency. Please note down accordingly. Call it as first and second equation. Now what you can do? Write down the third equation. General equation of slip is written as ns minus n divided by ns. Now what you can do is combining 1 and 2 into 3. Consider 1 and 2. That should be substituted in 3. So that I am able to get s equal to f dash upon f. From this you can separate the value of rotor frequency, which can be written as s into f. If you write this expression, that is more than sufficient to get the full marks. I think it's clear to everyone. Please practice once, pause the video and practice once. Better you only can write a notes. You only prepare a notes. I used to practice my own notes. I will be practicing. I never depend on any other Xerox material or something. Whatever before the examination, I used to write my own handwritten notes. That is my practice. So I also recommend the same practice to everyone. I think that will be helpful. Okay. Moving further, as you can see, the third question, describe the main parts of synchronous generator with the need sketches. It is having the weightage of 6 marks. You know, synchronous generator is nothing but it's an alternator, correct? No? So how to proceed further? You need to know the working of alternator. Alternator is also operating based on Faraday's law of electromagnetic induction. Without Faraday's law, no electrical engineering. That's my opinion. So definitely we are thankful to Michael Faraday. So need sketch of synchronous generator is mandatory. Weightage is 3 marks. Explain the components like rotor, DC excitation. Here we need to provide a DC excitation. Stator and stator core, then field magnet. It is having the weightage of 3 marks. Brief explanation is required. Also, anyway, you have to explain the diagram of a synchronous generator. Based on the rotor, synchronous generator is divided into 2 types. What are the 2 types of synchronous generator? Another question, another expected question, or else here also you can mention. One is called a salient pole type rotor, another one is called non-salient type motor. So if possible, give a brief explanation. It fetch you to score 6 marks. I think it's clear to everyone. So these are the questions from module 4. The second eighth one also from module 4 only. So let's discuss about question number 8. So as you can see, a 3-phase induction motor has 4 poles, is supplied from an alternator having 6 poles and running at 1000 rpm. Calculate the synchronous speed of the induction motor. Its speed when the slip is 0.004 and the frequency of rotor EMF when the speed is 600 rpm. Problem is very simple. Don't think that it's too complicated. Anyway, you know that supply will be given with the help of alternator. Induction motor is here for performing the mechanical work. Alternator output will be given to the induction motor, because in order to operate induction motor, electrical energy is required. So remember like this. So both are coupled. This is your alternator. Alternator produce electrical energy that will be given to where induction motor. This is the concept. What induction motor does, induction motor will provide the mechanical output. So let me write a mechanical energy. This is a concept. Now, please write down all the given data. Three-phase induction motor. Induction motor is having 4 poles. And alternator is having how many poles? 6 poles. Don't make any confusion. And the alternator is running at a speed of 1000 RPM. The rotor of the alternator has to be rotated at a speed of 1000 RPM to create the magnetic field. Correct now? Calculate the synchronous speed of induction motor. Then its speed when the slip is also given, and the frequency of rotor EMF when the speed is 600 RPM. So everybody please try to solve by your own. Later check the answer which I have written on the notes. So I'll be sharing the answer with you. Yeah, what I have done is I made a 2 column. First column 3-phase induction motor. Second column I have written as 3-phase synchronous generator, which is also known as alternator. Yeah. Now the synchronous speed of alternator need to be calculated. What is the formula of synchronous speed? Ns equal to 120 F by P. But I don't know the frequency. Who is providing the supply? Alternator will be providing the supply. How to calculate the supply frequency of alternator? Yes, there is a formula. F is nothing but supply frequency. Pn by 120. Therefore, the supply frequency is confirmed as 50 Hertz. Whatever the 50 Hertz is there now, that is the supply frequency. That will be given to this particular equation. Therefore, I am getting the synchronous speed equal to 1500 RPM. This is the first procedure. Definitely you will be getting 2 marks. Moving ahead. Speed of induction motor need to be calculated when the slip is equal to 0.004. Put slip value here. Compute the value of N. N is nothing but rotor speed. It is the actual speed of induction motor. Correct? Both are different. Rotor speed is represented as N. The synchronous speed is represented as Ns. So using this formula, please separate the value of N. I am getting 1440 RPM. Please do verify it. Okay, I request everyone to verify. Anyway, answer is right only, but from your side also you can do the verification. It is 2 marks. It carries 2 marks. The rotor frequency. See the rotor frequency. What is the formula for rotor frequency? F dash equal to S into F. But the slip we have to compute. When the speed is 600 RPM, correspondingly you need to calculate the slip. Okay, read the question carefully. They have mentioned very clearly what they have mentioned. I'll be showing you the question again. See, the question they have mentioned that. Please read the sentence. And frequency of the rotor EMF when the speed is 600 RPM. So please take the speed equal to rotor speed equal to 600 RPM in the last case. Coming back to the answer. What would be the answer? So check it up. So we'll be writing instead of N, I'm substituting 600. Anyway, synchronous speed will be same only, and the 120 F by P, that is 1500. Therefore, slip will be how much? 0.06. Anyway, rotor frequency has to be calculated corresponding to this data. F dash equal to S into F. Slip will be taken as 0.06. Frequency, supply frequency not change, 50 Hertz only. Multiply both, you'll be getting the rotor frequency of induction motor is equal to 30 Hertz. So you'll be getting full marks. Especially problem, you will be getting, nobody can stop you. They have to give, the evaluator has to give complete marks if you provide a sufficient unit, equation, and final answer. I think it's clear to everyone. Moving another part. Derive the EMF equation of synchronous generator. That is the EMF equation of alternator. That's also very simple if you know the Faraday's law. Okay, so what I have done is I have defined the parameter, what is F, what is P, what is N, what is set phase, what is T phase. All those things I derived. I have mentioned. So what I have done is what is set phase, what is T phase, everything I have written first. So here I haven't shown because it's an answer key, right? So whenever you are writing, you have to highlight everything. What is F, what is set phase, everything you have to write it neatly. Okay. Later, you have to mention about the frequency that is written as Pn by 120. Correct? Similarly, there is a relationship between the number of turn per phase and the number of conductor per phase. So T phase is nothing but set phase divided by 2. Very, very important relation. Kindly mark it. People are getting confusion. Even I am also getting confusion sometimes when I'm talking about the number of turn per phase and number of conductor per phase. That we have to mitigate. That we have to overcome. Yes, T phase can be written as set phase by 2. Okay. Now, what you can do is, this will be helpful for your problem also. T phase and set phase. T phase is equal to set phase by 2. However, let us directly move on to apply the Faraday's law. According to Faraday's law, E is equal to N d phi by dt. N I will be taking as 1. And E average can be written as d phi by dt. D phi means P phi. Same thing is applicable for DC generator also. dt can be written as 60 by ns, where ns is known as synchronous speed. While simplifying, I'll be getting P phi ns by 60. If you write up to this, definitely 2 marks is guaranteed. Then the frequency of the supply frequency can be written as Pns by 120. 120 is split up into 2 into 60. There is no problem now. 2 into 60, that is equal to 120. Mathematically, I can write. Now, from this expression, what I am going to do is 2, I'll be taking LHS. I think people may get confusion. No further confusion. So 2, I'll be taking the LHS side. Therefore, 2f will be written as Pns by 60. I think it's clear to everyone. Therefore, E average can be written as 2 phi f volts. It has the weightage of 2 marks. Then you need to compute the average EMF per turn. How to compute the average EMF per turn? See, average EMF per turn is equal to 2 into 2 phi f. Here you need to apply T phase and the relation between T phase and set phase. One turn is equal to 2 conductors, right? Therefore, E average can be written as 4f into phi into T phase volts. But we have to consider the virtual value. It is also known as RMS value, not average value. Okay, RMS value if you consider, then I'll be getting, there is a relation between RMS value and RMS value. Okay, RMS value and average value. So this is your average value. If you want to convert into RMS value, what you can do is, so multiply with the C. ERMS by E average is equal to 1.11. Correct, no? 1.11. This you already studied in your first module. Then ERMS can be written as 1.11 into E average. So ERMS becomes, what is E average? 4 into f into phi into T phase Kp Kd. Kp and Kd are the constants. One is pitch factor, another one is called distribution factor. It becomes 4.44. This will be the final answer. Please take care of this. 4.44 phi into T phase into Kp into Kd. Kp into Kd. So this much you are supposed to make out. This is the final answer. If you try it up to this, 6 marks is guaranteed. 6 out of 6 is guaranteed. I think it's clear to everyone. Last question from module 4, a problem. So here, read the problem very carefully. Kindly note down what are the data they have given. Here, remember that the 24 volt, then total conductors will be 144 into 10. Okay. That if you want to calculate in terms of set phase, I'll be telling you. Now, full pitch means you take Kp is equal to 1. Then Kd is already given 0.966. That's a distribution factor. Phi is also provided. Convert into SI unit. Now you need to calculate frequency, the magnitude of line voltage, output pin kVA, all those things you have to calculate. The line current is given as 50 amps. How to make out this? Very simple, don't worry. So I have already solved. I request everyone to solve once again. See, pole, then conductor. How to calculate conductor? 144 into 10. That is 1440. But I require conductor per phase. Okay, conductor turn per phase I have to calculate. Turn per phase is nothing but conductor per phase divided by 2. Since it is 3 phase, that is I will be multiplying with the 3. So set phase divided by 2 into 3. Therefore, I can confirm it as 240. You will be getting 1 mark. Kp, mention it as 1 because it's a full pitch. Kd also given. Phi, I have converted into SI unit. Frequency means the Pn by 120. I'm getting 50 hertz. E phase, apply the formula 4.44 F into 5 into P phase into Kp into Kd. This is actually RMS quantity only. That's why I have multiplied that, like ERMS by E average equal to 1.11. Therefore, ERMS equal to 1.11 into E average. I think you will follow. Then E phase I have computed, but what I require is I require line voltage. Line voltage and phase voltages are related in this fashion. Line voltage is equal to √3 times phase voltage, because they have already specified that the stator windings are star connected. Therefore, I am getting EL is equal to 5999.52 volt. Correct. Next, I need to calculate the KVA rating. What is KVA rating? It's apparent power, √3 EL IL. So EL into IL is already provided, that is 50. Therefore, I am getting 519.57 kV. So students, please verify the answer, it's correct or not. It's already correct. Okay, but from your side, you can verify it so that you will be getting a practice as well. So these are the questions from module 4. So in this session, I have discussed the probable question from module 3 and module 4. So in the upcoming session, one more session I am planning in the next day. In the coming session, I am going to discuss exclusively for module 5. Why I am explaining module 5 means it's that simple, and I want to give more tips on module 5. So that session will be really grateful if you watch my next video. Thank you very much for watching this video. If you are having any questions related to this particular discussion, please feel free to contact with me. I'm happy to answer. Thank you so much for watching this video. Let me conclude the session. Thank you.